Welcome to the second section of this course. In the previous section, we studied solid principles. You are now ready to dive right into the main concept of this course, design patterns. In this section, you will first get an introduction to design patterns in general before moving on to one of the most important design patterns in use today, the singleton pattern. Similar to the singleton pattern, we will study the factory pattern. After we're done with both of these patterns, we will work on our course project and utilize loose coupling to our advantage. Finally, we will talk about the object pool and how it can help us generate instances in a way different than the factory pattern. Just like you saw in the previous slide, you are about to be introduced to design patterns, a domain in software engineering that may appear daunting at first, but it gives you great strength once you master it. In this video, you're going to learn what design patterns are, what their categories are, and how we are going to apply all of that knowledge in a course project. In short, design patterns are, well, patterns that have been proven to be the best solution to some common problems in software engineering. Whenever you are stuck trying to devise a smart solution to a problem, chances are someone else had faced the same issue before you. One of the words that gets thrown around a lot in the software world is reusability. Another catch-all phrase is don't reinvent the wheel. You hear this a lot when someone says that you should always prefer to use a library rather than coding it yourself. The same applies to design patterns. Design patterns are the result of years of software engineering. Someone devised the perfect and simplest plan by breaking down the problem, and they provided a solution that you can openly use. Just like you may use a library to display a chart on your page instead of getting through the process of creating one yourself, you shouldn't apply custom solutions to architectural issues either. Every time you are struggling to come up with an architectural breakthrough, chances are there's a design pattern that will eventually provide a clean solution for you. Although most design patterns were made with object-oriented languages in mind, and that is why most examples you stumble upon online are in C#, Java, or C++, that does not mean they are tied to a specific language or framework. Once you learn a design pattern and can deeply understand it, then you are ready to apply to another language or framework with ease. Design patterns are grouped into three distinct groups depending on the problem they solve. First, we have creational design patterns. We will work with those in this section. Creational patterns are all about instantiating objects, how objects are instantiated, and how many instances of them we are allowed to create. Structural design patterns are about, you guessed it, the app's structure. Sometimes you have complex classes or objects that are composed from smaller classes or objects. Structural design patterns offer the most efficient way to work in situations like this and solve any challenges that may arise. Finally, behavioral patterns determine ways of application flow and how objects communicate with each other and how they interact with each other. We will be dedicating a section for each one of these groups. It is also now time to present you the course project. From now on, most design patterns will be explained in the context of a card game simulation. This card game, called Guardians of the Code, will have a player with a series of cards battling their way through enemy armies and bosses. This project provides opportunities to work with most design patterns in scenarios that mimic the real world. During the next sections and videos, we will be implementing the majority of the classes, interfaces, and structures necessary for this application to work. However, that does not mean that the app won't have room for you to experiment with it. So let us now begin the journey to the design patterns world.